What's up everyone, Patrick here, welcome back. Moving on to the next question. This one is a pretty cool, unique question. So we got two lines here. This line, ax plus 3y plus 4 equals 0, and then this line, 5x plus ay minus 2y minus 4 is equal to 0. And we have to figure out for what values of a are both of these lines going to be parallel. So when two lines are parallel, what does that mean? That means that they have the same slope. If two lines are parallel, they have the same slope. So what we can do is we could take both of these lines, I'm going to write them out over here. We could take this line, we could take this line. This one's going to be a little trickier to work with. And we could find the slope for both of them. It's going to be an expression for both of them in terms of a. And then we could just take both of those slopes, make them equal, and solve for a. So here, to get the slope, we got to put it into the y equals mx plus b format, which means we have to isolate for the y. So over here, I'm going to keep the 3y on the left side. I'm going to bring the ax over, that'll become negative ax. Bring the 4 over, that'll become minus 4. Then we could divide both sides by 3. So we'd have y equals negative a over 3x minus 4 over 3. So this line and this line are the exact same thing. And notice here, the slope for this line is negative a over 3. That's what we're looking for. And then same thing here. We want to get the slope for this line. So we got to isolate for the y. So isolating for the y is going to be a little trickier in this case, but it's still not too bad. So what we do is notice that there's two expressions that have a y attached to them. So we're going to leave both of these on the left side, and then the rest we'll bring over. So we bring the 5x over, that becomes negative 5x. Negative 4 comes over, that becomes positive 4. And remember, we're trying to isolate for the y. We could factor out a y from both of these. And then what we could do, we could divide everything by this expression, a minus 2. Because remember, that's just going to end up being some kind of number, right? A is just some kind of value, some kind of number, which we don't know what it is yet, but then a number, minus 2, gives us another number. So it's just the exact same process as if there was just a number in front here. Treat this bracket's like a number. So we divide this by that number, divide that by the number. And now notice the y ends up being by itself. And notice that the slope here is negative 5 over a minus 2x. So that's the slope. And then this here is the b value, which we don't really care about. We just care about the slope. So notice that the slope for this line is this over here. So this part was made the getting the slope a little bit trickier, but still not too bad. So this is the slope, this bracket. Okay, so let me write out these slopes. So the slope for this line, negative a over 3. And then the slope for this line is negative 5 over a minus 2. And so we got expressions for the slope. Now, if the lines are parallel, remember, what does that mean? It means the slopes are the same. So that means this has to equal that. And now we're just going to have an equation to solve. Right? So we could cross multiply. So we'll have negative a times a minus 2. Be careful with this is in a bracket. This times that, and then this times that gives us negative 15. And then this would be negative a squared plus 2a if we expand it. And then I'm going to bring this over to the right side to get a positive leading coefficient, meaning that the negative a squared is going to turn into a positive a squared minus 2a minus 15, like that. And now we just have a quadratic equation to solve. And fortunately, this quadratic, it actually factors smoothly into a minus 5, a plus 3. It's not always going to factor smoothly. Maybe you'd have to use the quadratic equation here and then get it in an exact value format, but fortunately in this case, it factors smoothly into a minus 5 times a plus 3. So a minus 5, when does that equal 0? Well, when a is equal to 5. And then when does a plus 3 equal 0? When a is equal to negative 3. So those are the two answers right there. So for those two a values, for either or, the two lines are going to be parallel. And then you could test it as well. You could take this a value of 5, plug it in. Well, notice if I plug it in here, I'll have negative 5 over 3. If I plug it in here, 5 minus 2 is 3. I'll have negative 5 over 3 for this line as well. If I take negative 3, negative times negative is positive. Positive 3 over positive 3 gives us positive 1. Negative 3, if I plug it in for a, notice I'll have a negative 5 in the denominator. Negative 5 divided by negative 5 is positive 1. Or you could take these values and plug them back in here and then put them both in y equals mx plus b form. That would take a little longer. Yeah, you'd plug in either or. You can't plug in like 5 for this line and then negative 3 for this line. You got to plug in 5 for both of them or negative 3 for both of them. But either way, those are the answers, and there is opportunity for you to check your answer as well.